there's one tiny thing about law of cosines that I haven't shown you. What is the law of cosines? What's the formula?
C squared equals A squared B squared minus 2 times A times B times cosine C.
C squared equals A squared plus B squared minus 2AB cosine of C. When we initially started writing out law of cosines, did anyone notice anything as I started writing it? C squared equals A squared plus B squared?
Yeah, that's what it is.
Pythagorean theorem is hidden within law of cosines. And that is because of their relationship to one another and the fact of really kind of where law of cosines came from. So, the one thing that I haven't shown you is that you can prove Pythagorean theorem using law of cosines. Hello. Oh, yes, please. Thank you. Thank you. So, that is going to be one of the things you're going to see today. Guys, I really don't want to be talking over you. Specifically, we can prove that it is a special case for the law of cosines. So, if we want to prove that it is a special case of the law of cosines, essentially, we're going to take our law of cosines and plug in what we know that makes sense, thank you, for Pythagorean theorem. What do you know about law of cosines? It's that, right? What do you know about Pythagorean theorem? Inside of it. We know more about Pythagorean theorem other than its connection to law of cosines. It's got to be a right triangle. So that's the key thing. If you want to write a proof for the Pythagorean theorem, you actually have to start this proof a way you've never started a proof before. Yes, we're doing a proof. But we're not doing a 2-column proof. In a 2-column proof, I say, given this, prove this. As you get into higher order mathematics, you don't do proofs like that anymore. They just say, prove it. And what you have to go into it with is you have to go into it with what are the requirements to make it happen. In order to show that Pythagorean theorem is a special case of the law of cosines, I have to work with a right triangle. So, to start these proofs, you have to tell me you're working with a right triangle. And you have to tell me probably a little bit more information. So, the beginning of this proof starts with a sentence. Let triangle ABC be a right triangle. But you need more information than that. You need a little bit more. So let triangle ABC be a right triangle such that. What makes a triangle a right triangle? Has a 90-degree angle. Has a right angle. In Pythagorean theorem, which angle is the right angle? Angle A, angle B, or angle C? It does matter. Where does the right angle have to be located in the triangle compared to side lengths? Across from the hypotenuse, opposite of the hypotenuse. Which is the hypotenuse in Pythagorean theorem, A, B, or C? C. So if side C is the hypotenuse, which angle is the right angle? Angle C. Such that angle C is a right angle. So you have to start with that. Now we're trying to prove Pythagorean theorem is a special case of law of cosines, so we're going to start with the law of cosines then, after we've got this piece out. Law of cosines works like this. C squared equals a squared plus b squared minus 2ab cosine of c. Ta-da, I wrote out the law of cosines. Now, I can start simplifying this because I know something. I know what my triangle ABC looks like. It looks like a right triangle such that angle C is a right angle. If angle C is a right angle, what do you know about it? Say it a little louder. I don't know who said it, but I heard it. It's 90 degrees. What can you simplify in law of cosines if you know angle C is 90 degrees? What can you plug in? Cosine of C is no longer cosine of C, it's cosine of 90. C squared equals a squared plus b squared minus 2ab cosine of 90 degrees. Cosine of 90 degrees is a number. What number? Cosine of 90 degrees is 0. You can use your unit circle, you can use your calculator. Either way, you're getting 0. What's going to happen when I put that 0 there? The minus 2ab is all gone. C squared equals a squared plus b squared. Our proof is done. You don't have to put that little box, but that is a little box that indicates the end of a proof. It's actually a little square. It's not a period. It's kind of like a period indicating it's the end of it. This is the proof. That's the entire thing. That's the entire set of notes that I had to give you. It is a proof. If you get into higher order mathematics, this is what the proofs look like. It's me showing you what proofs look like, and this proof might show up on the test.